Greetings everyone, welcome to the Torsion Lab introductory video. I had to make this new one kind of last minute because just on Friday we changed the plan based on equipment availability, material availability and whatnot. So here's the new video. There's a new machine, new software, new stuff, and so we printed out some instructions to guide you through it. I also put those up on the Canvas site. So you can preview the stuff there. I highly encourage you to preview the instructions. This is what the interface looks like. The key thing we need to see here is that it's 720 degrees per minute. 720 degrees per minute. That means 2 full twists per minute. Here's the chuck that the specimen goes into. You can jog it back and forth, analogous to moving the crosshead up and down. And it's a chuck just like you would use in the machine shop.
Like I said,
it's important to note that there's 3 flats that are ground onto the specimen. And as you can see in this next view here, the jaws of the chuck should grab on to the flat, align with or correspond to the flats on the specimen. I forget what this part is about here. Oh yeah, so once you have it in the one side, once you have it in the chuck, in the part that twists, you should reset the torque to be 0, right? And instead of right clicking, there's just a little button that says 0. I just put this in slow motion. You can see that the tailstock is free to slide, right? You can just slide that back and forth. The reason for that is that we don't want there to be a tensile load as we twist this thing. Now Jacob is going to jog the torque head around so that the flats on the tailstock line up with, and you can use the little thumb wheel or the big knob. That's the knob that goes fast, and the little thumb wheel does really slow adjustments. And you just have to make sure that the flats on the tailstock, or the flats on the specimen, align with the jaws on the tailstock there. And we'll get another view of that here. There's me in the red hoodie. So now he's going to tighten. Now he has those aligned, so he's going to tighten the chuck down. And there we go. The 3 flats aligned with the 3 jaws in the chuck.
Next step is to zero the angle channel. Because of the way that this data acquisition starts is once the angle channel passes 0.1 degrees, it starts data acquisition. But if you start the test with the angle channel at 1900 degrees, it won't start data acquisition beyond that.
The trigger is at 0.00.
Right. So you have to zero this angle channel. And then from there, test is ready to start. For visualization, we're going to We're going to draw a flat, and I'm just going to use some straight edge here to draw a line.
Yeah, the green marker line there with the Sharpie line is not really data. It's just to help us see, to visualize the twist, because you can't really tell if the steel twists on its own.
And that'll just give us a way to visualize how many rotations of twists this actually does go through. And then from here, we're ready to start the play. Let's start the test. So click play.
And once you push play, the test begins, and you can see the power head turns at 720 degrees a second, or per minute, 720 degrees per minute. And then the data show up on the display over there, and you can see just in a second here, that green line starts to make its way back around again, and you can see we put 1 full twist. Yeah, there's the tip of the green line. 1 full twist in the specimen already. You can see here that we're actually reading a negative torque. That's just due to the orientation of the torque cell versus the direction of the motor. So you see that as the torque increases, it just looks like a negative torque.
And unlike the tension tests on the MTS machines, this does not have automatic brake detect activated. So once the sample breaks, the head will still rotate, so you'll have to manually stop the test. There we go. So that's our brake. But the icon, and I will save the test data, and I can give it a... So I'll just call this TA data, A36 for our TA training, and click OK. And as students, they would save the data to a very specific name so that they can find it again, because once you save the data, you have to go into...
Now when you save these data, it saves in an ADMET proprietary format, so then you have to export your data into a CSV file, comma separated variable file. So it's very, very important you do that, and then save it to your jump drive, your USB drive, and then you'll have some data that you can import into Excel and you can actually use.
So once we have fracture of our specimen, we can slide the tailstock away. We need to make sure that the adjustment for the jaws is available for us to loosen the jaws, so we can rotate the headstock as appropriate. Remove our part, and be careful because this is going to be a sharp edge, so don't bump your hand on